Good afternoon, and to some of you also good morning. My name is Zuzana Špitálová, and I'm a PhD research student at the Slovak University of Technology in Bratislava at the Faculty of Informatics and Information Technology. And today I would like to present you our work, concept of delivery system in the smart city environment. This work I was preparing with my colleagues from the university, which are Leontiev and Patrik Harmaňoš. These colleagues are also the part of our faculty. And so at our faculty, we have some research groups, and every one of us belongs to the Automotive Innovation Lab groups, which is dealing with the topics like vehicle to everything communication, cloud, smart city, or IoT topics. So because of that, we are working on the projects which are related to these main topics, also which are related to the applications which are needed for some smart environment or vehicle to everything communication and so on. So at the beginning, I would like to briefly talk about the content of this presentation. So firstly, I would like to briefly introduce what is the smart city environment. Then I will talk about the target of our project. After this target, I would like to mention that our system consists of front-end and backend part, which I will talking about. Then there is a testing part which were done with our system, and after that I would like to mention some brief plans for the future work which we would like to do with this design system. So I can start with the smart city environment. There are many definitions of that, but according to the most of sources, smart city is defined as the place which uses the modern technical solutions for conventional services and networks for improving the daily life of the people which live there. There are also many information and communication technologies used in this environment, and between them there are some artificial intelligence technologies, machine learning, 5G networks, and many others. They have in common that they are used in this environment. And if we talk about these technologies, there can also be every personal mobile phone used like the ICT, and via this mobile, the very useful information can be gained and used in the smart city environment for some improvings. Regarding also to these cities, there are some rankings done periodically, and this ranking is related to the certain level of smart which the cities can achieve. And there are various aspects which are taken into consideration if we talk about the smart city. The main focus of of that is the integration of urban technologies, sensors, and any personal device. And as I mentioned, this personal device can be every personal mobile phone and every app which runs on this mobile phone. Also, we have some ideal case if we talk about the smart city, and the ideal case is to have some citizen cloud. The citizen cloud represents the platform which is able to provide us some services like culture, healthcare, or some transportation system, for example. And all this information which are shared at the, in this platform can be also used for the improvements of this environment of smart city. Here at this slide, I have the target of our work. So the target of our work was the delivery system. So the main idea is the shared delivery system in case of the same direction of delivered parcel and traveling person. So everyone in this community can participate in the delivery process. So we wanted to create the open source project which could be used by various people delivering the items during the traveling to school or work. If the destination address of the delivered item would be the same as they intend to reach. So, and this could help to save time, money, and also other sources which are used for the package delivering. And as the smart city environment is also ranked according to the implementation by various technologies and devices used inside it, the other aim of our project is the usage in the urban area, where will be the possibility to gain this various data regarding to traffic, like concentration of cars, number of daily orders, and many others. And as I mentioned before, so this gain data can be processed and used for also for other purposes. And according to that, there can be some definition of green and busy zones, some peakouts, and many other assets regarding to the daily life in the cities. So as this system is shared, so we can also say that our proposed system belongs to the green concept. Yeah. And the information about the system which is important is that this system is different from the commercial ones due to this data collecting and the possible usage of that. The system itself consists of front-end and back-end application. Front-end application was designed for mobile phones, and we defined some requirements for that, which we had to fulfill. So as we can see on the slide, the first one is the easy usage requirement. This we were able to achieve by questionnaire related to the navigation between screens. So according to this information, we were able to design that. The second one is the fast response requirement. And to achieve this requirement, we can say that the native implementation is needed. We have also cross and native frameworks, and the main difference between them is that the native is the targeted platform. Yeah, so due to that, the native one is faster because it's targeted to the single mobile platform. The other requirement is the mentioned multi-platform usage. There are various frameworks for that, but we chose the ReactNative one, which is open source, and development ID runs under various operation systems like Mac, Windows, or Linux. The other requirement is the data encryption requirement. Because of the need of local storage data on the mobile phone, and to achieve this requirement, we used async storage for some non-sensitive data and secure storage for sensitive data, which can be needed to be stored on the local storage on the mobile phone. And the other requirement is secure communication. This is achieved by HTTPS tokens during the authentication. So this means that after login, there is the access token necessary for authorization. And during this login, it's gained. And this token, it has two parts. It's the access token and the renew token. And the renew token provides the backup for this main access token. So if there is some problem, maybe if this token is not valid, the renew one is used. And if also the renew one is not valid, so the other login is needed for generating the new tokens, the access one and also the renew one. Yeah, it's to the HTTPS tokens. The other requirement is simple API for communication. For that requirement, the REST API is used for data exchanging, but for more details, I will be talking about that on the next slides. The other requirement is the modularity. To achieve this this is achieved by easy to extend possibility, because it's not developed like bundled component application, but it's developed like module one. So we use the layered system of the components, so it can be very easy to extend the application if it is needed. And the last requirement is the open source possibility. This possibility is in plan for some future work on this project. Yeah, and now I would like to talk about the roles which are available in the front-end application of our system. So as I told that the system is for shared delivery, you can choose by front-end two roles. One role is the user role, the second is the courier role, so the delivery person role. And by user role, there is a need for another role selection, because if you are the user of this app, you can act as a sender of some delivery package or as a receiver of some delivery package. If you choose the role of the sender, so you have to fill some required information. So it's your address, the destination address, some information about the package which you would like to send. And after that, your delivery package is created. And after this creation, there could be this receiver role, and this receiver role could be the receiver of your package, and this person obtain the link for tracking the package which you are sending by some courier. So this receiver role doesn't need the registration, because this role can just track the package on the road during the delivery process. By the courier role, there is the registration required. So after logging into the application, you have to register as the courier, and there are also some other information which has to be fulfilled. For example, the information about the means of transport which you use, and the other information, or not information, other requirement is the location sharing. So if you would like to use this courier role, you have to enable your location on the mobile phone. This is because of the package delivery tracking. So like courier, after the registration, after this location sharing enabling, you can choose some package which is in your nearby, and you can start the delivery process. After this delivery process is the main idea is the respect of good manners. So we expect some certain community which can help can help each other, yeah. So that every person can help to other person with some delivery process. So it's not a commercial one. And here we can see some screens of our application. Sorry, it's in Slovak language, but I will explain what is here. So the first one, we can see the screen with accepted order by the courier. So the first is the source address, so the address of the sender. And the second is the destination address. And here is the distance between these 2 points. So courier can see what is the distance before accepting this package for delivery. The second screen is just the screen of package pickup. So if the courier register into the application, he can see the available packages for delivery with the address, with the source address of this package. And the third one is the delivered package. So at this screen, we can see all the route of the courier from the source to destination address. Here is the destination address. And the last thing what the courier has to do is to mark that the delivery package was delivered. So after the delivery, after this delivery, the courier is the person which mark the package like delivered. Or if there is some problem with the delivery, he can also mark this package like not delivered. If this happens, as it is open source and it's shared in this community, So this courier and the person which sends the package has to communicate about this. So we didn't think about some place where to leave these packages which are not delivered. So for example, he can try it next time or maybe in some hours. And at this screen, we can see the position of the courier. So after the acceptance of the delivery package, the receiver of this package can see the location of the courier, and the location is tracked by sending his location every 4 seconds, by his mobile phone. And what we can see that this car is like our courier, and we can see the movement of him. Okay, here on this slide, we have some APIs, as I mentioned before, and these APIs are, sorry, these APIs are used for communication between front-end and back-end part of our system. So if I want some, for example, some new user creation or verification of email, I normally used post APIs, or maybe some requirements for tokens or data changing. So we have get or patch APIs or post APIs. This is used according to the item which I need between this communication with server part. Yeah, so this was just about the front-end application of our system. Here we have the backend part, and the backend part is this part runs like the Linux container, and we have also some requirements for that and ways how to achieve this requirement. So the first requirement is the fast processing and the response. And to achieve this, there are various databases, but we chose PostrgreSQL because of the relational database management system, which provides us the relational database management functionality. And the data in this database is stored in the tables. And these RDBMS ensures the integrity and rules between the databases. So this is integrated with the Django Python modules, which we use also for our backend. And the web server part is covered by nginx server, which runs on Debian. So this is for the fast processing and response. The other requirement is secure communication, which used JSON web tokens. So this is the topic with authentication, which I mentioned by the front-end part. Data encryptions data encryptions used these special algorithms for encrypting. The other requirements is scalability. These requirements can be achieved by mentioned container-based running. After that, we have the other requirements, which is easy maintenance. So for that, we have our administration tools, and the last requirements is the open source possibility. So this is also for the future work which we plan with this system. On this slide, you can see the tables or the relation between the tables in the database, and here there are expressed other roles which we also have in the front-end part. For example, for the account, we need email, password, if this account is for admin, if this account is active. Also, for some person which is registered, we need first name, last name, some phone number, email. For the courier, here are also some special information which are required. For the delivery, it's the same, yeah. So the state of this delivery item, route distance, expected duration, which is also calculated thanks to the Google API, which is used. And the price is not it's not mandatory, because it's just for some, maybe for some future use, but it was not thought. We were not thinking about it. Also, we have the table for the places, so it means the table for the addresses, like this source, destination, some coordinates, and the routes which are created also for courier and for the delivered package. After that, when we created this logical model for these relations between tables, we were also considered some changes, and we changed the items like courier vehicle type. So we were thinking about the vehicle type specifically, so if it's car, if it's some scooter, and so on. Now we have small, medium, large, and it doesn't matter what kind of car it is. This item and the weight, if it's light, medium, heavy, so it's not necessary to fill the specific weight. And the delivery state, so we created the 5 possibilities. So the delivery item could be ready for delivering, assigned. So it's like it's assigned to some courier. It's in delivering, which is delivery process, delivered. So this means that the receiver has his package, and undeliverable. This means that the package was not able to deliver. And when we created our system consisted of front-end and backend, we also we also did some testing. We tested functional and the non-functional requirements. The tests were done manually and automatically, and each functionality was tested after the implementation. And we have also some milestones for our system, and the whole app and the whole system was tested also after implementation, all the features which were required for the specific milestones. And here I have some results from another testing of front-end part. So the front-end part of our system was also tested by 5 users in the first phase. And five users were tested this application from the user-friendly point of view. So we have some tasks which which had to be executed. These tasks were very related to this specific requirements like login, some package delivery creation, and so on. And only one user was not able to make all the requirements. So here was the problem with the courier registration. So our user 5 was not able to find the specific screen for this registration. And as we can see at this graphical here, so which we have the unnecessary steps for doing all these tests. So he is the winner in the number. So there was some problem with the courier registration creation. Another metric was the number of identified failures in the system. So each of the user found some mistakes. These mistakes were fixed, and the tests were executed again. And the last graphical talks us or represents us the system usability scale method. So this method consists of a questionnaire of 10 questions regarding to the app usability, and it could be ranked from 1 to 5, where 5 is the best score. And after the calculation, you can find the percentage of this system usability scale. On this slide, we have also some results from backend testing. So every request from the front-end part to the backend was made by manual and automatic tests, and the average time for the requests are here in these tables. So these times are not so bad, but maybe the other system with other performance will have better some better results. These items which doesn't have any number are the items which didn't need or didn't require the time, but just some action. For example, this email sending was the email which are sent after registration or after creation the delivery package. So because of that, there are no numbers here. And here we have some plans for future work with the system, because the system is now designed for usage. It was tested, but we need also more people which can test that. And we would like to do this system really open source, so implemented it, for example, in GitLab, as the community can also contribute in this system, and also thanks to this could be better done, and also this could be more robust. The other plan is some analysis from the gain data which we have. So, for example, definition of some rush hours in the zones, or some kind of types or type of vehicles which are driving in the certain area, and so on. And the last plan is add more inputs to the systems like sensors. So now we would like to use this application with a scooter with electrical scooter, which will have some sensors which are able to gain the other data, and all this gained information will be processed by our backend. So this is some brief information about the future work. And so this is all from my side. Thank you for your attention. And if you have any question, so feel free to ask.